matrices?
Good word. Homework's chill. Yeah, 5 minutes. Something like that.
Five of your homework this last time, I noticed some of you got this wrong, so I want to go over this. The way they said it is to express each of the following vectors in terms of its magnitude and unit vector, indicating that's a weirdo way to ask that question. It's just, this is the way you're going to see that asked. Find the unit vector that's going in the same direction. I'm not sure how to immunize you against misunderstanding the question, other than if you see the words unit vector, that's where you go to the formula sheet of how to find a unit vector. It has to be something to do with that. How do you do it? So let me give you a few of these. -4, 3, and they ask you for the unit vector and then going in the same direction. So what's happening is here you have -4, 1, 2, 3 up here. That's -4, 3, the vector. It doesn't have size 1. You're going to make it have size 1 by finding what to scale it down by. So if you take this vector, step 1 is to find the magnitude. Maybe those words were placed here to help you along a little bit more. They're not helpful because the questions just find the unit vector going in the same direction. So find the magnitude of the vector. You're going to get -4 squared plus 3 squared, which turns out to be 25, which is 5. That's the magnitude. Step 2 is to take that magnitude and divide through the entire vector.
I like only seeing.
There's a lot of geometry behind this. So really what's happening is you took this original vector and you scaled it down so it had size 1. If you took the magnitude of this guy, I did that in class, you're going to find that it has magnitude 1. So it's going to lower it down. Same direction, but only has size 1. And we do that for normalization purposes. I do it all the time in machine learning. I have to normalize the vectors I have by scaling them down to having unit size. Let me see if there was something else. I did want to show you one last thing. So if I want to take a vector and do something to it, which is exactly what's happening when you're using your cell phone. You have the screen, you want to move something from one point to the other, you actually take your finger and you slide that point over. What's happening behind the scenes is you're multiplying by a matrix, and that's really the power of matrices. It makes computations possible that on the phone. And so if you take, for example, the vector 1, 1, and I want to move it over here, like so, take the matrix, this, and multiply it to the vector. This is another form of putting your vectors. You actually would take it so you multiply by this matrix. So if you do this dot product right here, you get -1. You do this product right here, you get 1. And look over here, that's exactly -1, 1. It may be. That's the whole point of what you're doing. I'm not sure where we're going with this, but that's where you're going to see this used. It's that you're taking things and moving it or stretching it by matrix multiplication. And why we do this is it's easier to store this than it is to store every possible vector and everything that you're doing separately. That's why it is. I can imagine a question like this being asked. I don't know where it's going. So I don't want you to be surprised if you see something like this. Like, this is what it does. It acts upon the matrices act upon the vectors and do things to them. Are there any questions? You ready for one of these again tomorrow and the day after? Like, just keep trying them.